Okay, for this question, triangle ABC has vertices A11, B31, C12. There. Then triangle DEF has vertices -1, -1 for D, E -1, -3, and F is -2, -1 in here. The matrix P represents a single transformation T that maps triangle ABC onto DEF. ABC is mapped onto DEF. Describe fully, T fully, this transformation. When we look at these triangles, if I were to put my ruler over here and I were to draw a line, let's say from here to here, I can clearly see that this is nothing but a reflection in the line. So this triangle is reflected in this line and comes here. This is the line y is equal to -x. So what I'm going to say is that the single transformation is, describe it, so it's a reflection in the line y is equal to -x, represented by the matrix -1, 0, -1, -1, 0. That's matrix for reflection in the line y is equal to -x. Write down the matrix. Oh well, there we go. 0, -1, -1, 0. You can test. For example, 3, 1, if you take, let's say test 0, -1, -1, 0, you multiply by 3, 1, you get -1, -3. And here you got -1, -3. That's E. Okay, so this first part is done. Second part, another transformation is represented by the matrix Q, where Q is 0, -0, -1, 1, 0. This transformation maps B onto Y. Find the coordinates of Y. Okay, to find the coordinates of Y, 0, -1, 1, 0, multiply by what is being transformed is B. So B is the coordinate 3, 1, so I'm going to multiply by 3, 1, and if you multiply that out, you should be able to get -1, 3. So the answer is then, find the coordinates of Y. Y is -1, 3. Here we are. Okay, and for the other transformation, this transformation K, the same transformation, this is a different transformation now, this transformation maps K onto C. Well, what is the coordinate of C? It is 1, 2. Okay, so what are we saying? That the transformation Q maps K onto C. So Q times K, then we are going to get C. Alright, if that's the case, we need to find the coordinates of K. Alright, so how can we do this? Basically, we're going to say that K is equal to, let us see, I can say K from here is equal to, if you send Q on the other side, becomes inverse of Q times C. Let's find the inverse of Q. So Q inverse is going to equal to, you can put the -1 down and the 1 up, 0, 0. Find the determinant, 0 minus -1 is +1. So 1 over 1, and so we got the inverse as 0, 1, -1, 0. So we're going to use that inverse to find K. So K is going to equal to 0, 1, -1, 0, multiplied by C, and the coordinates of C, as you can see, is 1, 2. So if you do that, you should be able to get 2 minus 1. And therefore the answer to the question is K is 2 and then -1. Here we are. Done. Describe fully the single transformation which is represented by Q. Okay, if we look carefully, that this point What are we being told? B is mapped onto Y, so B goes onto Y. And we found that Y was minus 1, 3. So minus 1, 3. So there we go. So B has gone there. So if this is B, it has gone there. Now, what do we make of this? If I draw my line here, okay, let's say this is the center. I suspect that this is a rotation of 90 degrees, and it seems I'm right. We can prove it if you want, and if needed. Well, this is 90 degrees, so we clearly see it's a rotation. So it's an anti-clockwise rotation of 90 degrees. So I'm going to say anti-clockwise rotation, okay, just write it here, rotation of 90 degrees about the origin O, about this center here. Alright, so next, the matrix R is given by Q is equal to RP. So what about Q is equal to RP? What do we make of this? Alright, and we need to find by considering the effects of transformations on triangle ABC, or otherwise, I'm going to use otherwise, find R. It's a lot easier for me. Alright, we need to find R. So what is R? Now, I got RP is equal to Q. Therefore, R is equal to Q. If you send P on the other side, you take the inverse of P. Now, remember the matrix P was found to be 0, minus 1, 1, minus 1, 0. Therefore, the inverse of P is going to be equal to 0, 1, 1, 0. Right, that's the inverse. So basically we're saying Q, which we know already is 0, 1, 1, minus 1, 0. So we're going to take 0, minus 1, 1, 0, multiply by the inverse of P, which we just said 0, 1, 1, 0. And we should be able to get an answer for R. So this is this minus 1, multiply row times column. So this is going to be equal to 0. Row column, so 0 again, row column, so I got, hang on a second, just one moment, I might have made a mistake here, no, so let's go back to this, let's find the inverse of P. I'm going to do it somewhere here, the inverse of P. What is P? P is equal to, I've been a bit too quick here, so 0, minus 1, minus 1, 0. Let's find the determinant of this matrix. Determinant is 0, minus 1 times minus 1 is 1, so 0 minus 1 is minus 1. Then I've got the matrix, if I want to find its inverse. So I'm going to have to put 0, 0, and this becomes plus and plus, and then times minus. So it is then 0, minus 1, minus 1. So the inverse is again this. So the inverse is supposed to be here, minus 1, minus 1. There we go. Now it's going to be all right. So we're going to get this as, let's got to be careful with this, because it's not what we think that that certain answers are. We have to verify by calculation. So a simple verification here has saved us a big mistake. So then 1 times minus 1 is 1, 0 times 0 is 0, so that's going to be minus 1. So here we go. So this is the matrix R. Now the point H lies onto DC produce. So this is D to C. And there's a point H lying on this line when it's produced. So what I'm going to do is, let me just save you this thing here. And let's put this as the line, DC. It's a vector, so DC here, and then point H is lying somewhere there. So when DC is produced, and get the point H, maybe the line continues. We need to find the ratio of DC's to DH. Okay, so what is DC? That's the point. The vector DC is here, D to C. If you want to move from D to C, you're going to move along x 1, 2, and then along y 1, 2, 3. So we got DC as 2, 3. Now you see this 18 and you see this 2, so we want DC is to DH. So DC over DH is going to equal to 8, so this is over 18, this is 2, so 2 over 18. So that's going to give us 1 over 9. So the answer to the question here is 1 is to 9. Here we are. Then the last part of the question, we need to find the value of h. Now you remember when 3 points, or all points lying on the same line, we've got collinear points. So here we're going to use collinear points. So what we know is DCH lies on the same line. So if I say DC multiplied by K, I must be able to get DH. So what is DC? And DC is this, 2, 3. So I'm going to say, then let's border this off. And this is the second part. So DC times K is equal to DH. And I've got DC is at 2, so 2 times K is equal to 18. That means K is equal to 9. Then I've got 3 times K is equal to H. So 3 times 9 is equal to H. So H is equal to 27. So the answer here is 27. Here we are. Done.